square root of a plus square root of b is equal to square root of 2009, where a and b belong to whole numbers and we have to solve for a and b. So basically we are given two numbers a and b which are belonging to whole numbers, and we are given this equation. From this equation we have to deduce the value of a and b. So let's see how we can solve this, and it is a very basic question from number theory, so let's see how we can evaluate it. So in these kinds of problems we basically establish a relationship between we find a relationship that what can be the possible form of a and what can be the possible form of b. That is, let me explain you. So let's bring square root of b to RHS. You will get square root of a is square root of 2009 minus square root of b. Now just square both sides. So let's see what you will get. This is a, this is 2009 minus 2 times the quantity, this is square root, into b plus square root of b square is equal to b. So you can say that minus 2 times the square root of this quantity 2009 b, right? Okay. Now notice one thing over here. A is belonging to whole number, right? It means that since, which implies LHS is belonging to whole numbers, which implies that RHS should also belong to whole number, right? Okay. So 2009 plus b belongs to whole number, right? But we have to check for this. Well, this expression will only belong to whole number if this square root is a perfect square. Now when can it be a perfect square? Well, let's see. 2009, can it be further factorized? Well, it is divisible by 7, and if you check it further, it is divisible by 7 square actually. So it is equal to 49 times 41, right? You can multiply also and check. Let me show you also if you have doubt. No need of this, you can just write 50 minus 1, 41, so it will be equal to 100 by 2, 41 minus 41, so you will get 0.5. So it is 2050 minus 41, which is 2009, right? So this is actually equal to 49 to 41. Okay. So clearly this is a perfect square. So it is 7 square times 41. So you can write this square root term as square root of 2009b as equal to square root of 7 square times 41, and we all know that 41 is a prime number, right? Okay, times b, correct? So clearly you can bring 7 outside, so you'll get 7 times 41b, right? So you got this expression. Now earlier I said that in such kind of problems we establish a relation between the variable, the given variable which we have to reduce, which we have to find in terms of some conditions. That is, what is the condition over here? The condition is that this square root term must be, the input of this square root term should be a perfect square, which means that b must be of the form 41 times some alpha square, where alpha belongs to whole numbers. Since a and b belongs to whole numbers, so it means that alpha should also belong to whole numbers. Okay. So clearly, or maybe you can say alpha belongs to some integer, because of course we have alpha square, so even if alpha is negative, then also it will be equal to what? Alpha square will be positive. So b is again a whole number, so alpha can belong to integers. Okay. So we have deduced the relation that b is equal to some 41 into alpha square. Okay, now you can just reverse the process. I mean, instead of A you can write B, and instead of B you can write A. So B is equal to this into this into this plus this. So you will have B is equal to this and this. So B belongs to this. So this is okay, and plus A. So this will be A, this will be A, and this will be also A, right? So from here you can say that just from the symmetricity of the equation, you can clearly say that over here A should also be equal to 41 beta square. So it means that both A and B should be a square multiple of 41, and alpha and beta both can belong to integers. Okay, so we have deduced the relation that alpha is equal to 41, sorry, B is equal to alpha square, and A is equal to 41 beta square. Now of course alpha looks pretty good with A, so I will write it as alpha square and it as beta square. Okay, because it matches a bit, so that is why I'm just changing the variable. It doesn't matter. Okay, so we have proved this thing. Now let's use this in the equation. So let me erase this first of all. So we had found that A is 41 times alpha square and B is 41 times beta square, where alpha and beta belongs to integers. Okay, so now we have this expression which we are given. So let's solve for alpha and beta. Just substitute over here. You will get 41 alpha square plus 41 beta square is equal to square root of 41 times 49. So square root of 41 times modulus of alpha plus modulus of beta is equal to square root of 41 times 7. So 41 and 41 gets cancelled. So you have the expression alpha plus beta is 7, right? Now we all know that since in the expression of A and B we have alpha square and beta square, so it doesn't matter what will be the sign of alpha and beta, right? So what I'm going to do is that I can simply solve for this equation alpha plus beta is equal to 7 to get the answer. Okay, so we have this expression. So when you will solve it, let's see what we get. So beta is 7 minus alpha, and now alpha comma beta belongs to whole numbers. Okay, so we have this quantity. Let me explain also if you didn't understand over there. Square root of 4, it is 2, not plus minus 2. Okay, but we know that negative 2 square is also equal to 2, I mean 4, and 2 square is also equal to 4, right? Okay, so it means that square root of negative 2 whole square is equal to 2, and square root of 2 square is again equal to 2, because square root of x square is modulus of x. So instead of considering all these things, we can simply assume that alpha and beta belongs to whole numbers, because at last we are getting this expression only a positive value. So let's assume alpha and beta as whole numbers. Okay, so let's erase this. So we had got alpha is 7 minus beta, right? Okay, so what is alpha comma beta, right? Let's see it. Or I can write over here beta minus alpha, so it becomes more easy to comprehend. So 0 comma 7, 1 comma 6, 2 comma 5, 3 comma 4 till 7 comma 0. Okay, right? Now we know that A is 41 alpha square and B is 41 beta square. So you can clearly say A comma B is equal to, when alpha is 0, beta is equal to 7. So it is 0 comma 41 times 7 square, comma, when alpha is equal to 1, then beta is equal to, sorry, when alpha is equal to 1, then beta is equal to 6 and a is equal to 41 comma, 41 into 6 square, comma, when alpha is equal to, then a is equal to 41 into 2 square, comma, 2 square, comma, 41 into 5 square, and so on till when alpha is equal to 7, then a is equal to 41. I can write over here only 41 into 7 square, comma 0. Okay, so here are 8 possible answers. Okay, now clearly if you assume the negative signs, then also square would have adjusted everything, so we don't need to think about that. Okay, so that is the answer, and you can solve it further, right? So I hope you enjoyed this video. If you did, then please do like, share, subscribe, and please support this video. And you can check out my other videos also. I make videos on bachelor's and master's courses, and sometimes for 11th and 12th grade also, and I cover many different types of questions which you will never find on YouTube. So please subscribe this channel and please support this video for this valuable content. Bye bye, take care.